Okay, so here I'm going to look at the area, and that's 1/2. I mean, that's not 1/2 because I'm doing the average here. So it's the average velocity times, I don't know what T2 is. This is delta T12, but since T1 is equal to 0, delta T12 is just equal to T2. And this is equal to the area under the curve, which is R2 minus R1 as I go from event 1 to event 2, which is 15 meters. So I can use this to find T2. T2 is equal to 15 meters divided by 9 meters per second. If I have seconds in the denominator of the denominator, they can come up to the numerator, the meters cancel out, and 15 divided by 9 is 1.67 seconds. I don't want to round it to any less than 3 significant figures. So I'm going to keep 3 significant figures along the way. You could round it to 1.7 when you put it on the table. When you calculate T3, you want to use the 1.67. And now that I know T2, I can say T3 is 4.07 seconds. I looked at the area going from event 1 to event 2. Now I want to look at the slope. Slope is change in velocity over change in time and is equal to the acceleration, which I do not know. So change in velocity, that's 3 meters per second. Final velocity, so in this case V2, minus initial velocity, in this case V1, so 15 meters per second, divided by change in time, which is 1.67 seconds. And that gives us negative, since V1 is greater than V2, 7.2 meters per second squared. I'm going to box this and then put it in my table up here. Negative 7.2 meters per second squared. I would like you to box what you're putting in your table because it helps me when I'm grading to see where you did your calculations. Also, if you can label your work if there's more than 2 events, going from event 1 to event 2, separately from going from event 2 to event 3, so that I can find things on your page. For these problems, you really should have enough room on one page for all your work, but if you run out of room, you can, for your homework, finish the problem on a blank piece of paper, scan them both. Remember to submit it as one PDF file, but if you need to go on to a different piece of paper to finish your work, you can do that. But make it very clear to me that there isn't another piece of paper that I should be looking at. Otherwise, I might not realize that your work goes on to another page. So on the top of your page, if you have to go on to a separate sheet of paper, really large across the top, say work continued on separate page, like this. Okay, nice and big at the top. I'm not actually continuing my work. Oops, continued. I'm not actually continuing my work on another page, so we'll cross that out. Okay, but that's what I would want you to do. Okay, so now as I go from event 2 to event 3, I'm going to do the same thing. Now conveniently, because we're ending at the same speed that we started from, the average velocity as I go from event 2 to event 3 is also 9 meters per second. Okay, and I must not have drawn it correctly because this area and this area are supposed to be the same. Okay, and so I do area. I don't know what R3 is, so let me just call this delta R23. This is equal to the base, which is the change. This is delta T23. So I don't want the 4.07, I want delta T23, which is equal to 2.4 seconds. So the change in time, the base, times the height, when I use the average velocity. So if you use the average velocity, it's a rectangle. Base times height gives me the area. 2.4 times 9 is 21.6 meters. I box, no, wait, I don't box it because this is not what goes in the table. What goes in the table is R3. So R3 is equal to 21.6 meters plus 15 meters, which is 36.6 meters. And if you want to round it to 37, go ahead and round it to 37. But I'm going to put it up here as 36.6 meters. We looked at the area. Now we look at the slope. Slope is acceleration, change in velocity over change in time. So final velocity minus initial velocity as I go from 2 to 3. Final velocity is v3, that's 15 meters per second, minus initial velocity, which is v2, over change in time, which is 2.4 seconds. Okay, so let me write this over here also. Change in velocity over change in time, you can write that as v3 minus v2 over t3 minus t2. And we get 5 meters per second squared. This is positive, which it should be. Whoops, I'm not supposed to do that. Okay, so this acceleration is negative, this acceleration is positive, this slope is negative, this slope is positive, and I was wrong. The slope should actually be steeper for the first part of the graph because 7.2 is greater than 5, but I was still able to solve the problem correctly. Okay, and let's take a peek at the answer in the back of the Model 1. So this has a subscript 5. So I go back here, and they told me that R3 is 36.6. Now notice that I could get the 36.6 right, but since I didn't use that for the acceleration, my acceleration might be wrong. But if you got the 36.6 right, you probably got the 1.67 and the negative 7.2 right. So you would have most everything correct if you got the 36.6. Okay, so that concludes problem 46.